discuss about the union find cycle detection algorithm. The method for the union find is for each edge. We will make new subsets using both of the vertices of the edge. And then, if both of the vertices are in the same subsets, then the cycle is found. This is the illustration of a graph that has cycle. We added one more node to see that we have a cycle vertices A, B, and C.
If you are familiar with the crosscuts algorithm, it is an algorithm for finding a minimum spanning tree. So why is this important to be mentioned with this topic? It is because of the step 3 of the process. As you can see that we have to check if each form of a cycle with a current spanning tree. This is one of the many ways in using the union find method. It is very important in this method of application.
Let's go over into the terminologies. So we will use the graph example from before. We have our nodes A, B, C, and D. Then we will form the sets based from the graph. A, B, and C could form a set and D could form another. So we have our find query. Our find query could be, for instance, our nodes B and D are in the same set. And the answer is no. And then we have the union command to merge sets. So we will merge the elements containing B and D. And then we will have one set as we merge the two sets containing B and D. You see, this is why it is important. For example, look at this network and we ask if A and B are in the same connected set. You can see here they aren't, but imagine the network and ask the same kind of question. So let's go for the initial idea. So for the pair of nodes, if the find U and V are equal, therefore cycle is detected. Otherwise, put U and V in the same set with a union operation. This is all the algorithm is. It is very straightforward and very clever. Okay, so let's look at the example on how this run through. And we'll use another concept here of having a parent. We will track any two pairs of nodes. We will assign one of them to the parent. So this will be used as a tracking purposes. We will label numerically to understand the method easily. We'll initialize the parent value to -1. This means that the node is connected to itself, or it is looping on itself, or self-loop. So let's start with a given pair of edges. We'll pick the 0 and 1 pair. We're gonna go with all the pair, but we will go for this at the moment. So we'll run our find operation on these two nodes, 0 and 1, to find the return values of the nodes 0 and 1. And because the find value is not equal, we're gonna make a union of 0 and 1 and put this 2 in one set. This shows that the green line in the graph on the screen. So let's proceed to the next edge. As we make the union, we have to assign a value to the parent of the node. In this case, we'll put 1 as the parent of the node. So now let's proceed to the next edge pair, the 0 and 2. We will have to find the operation on 0, which is equal to 1, because we did that before and it actually now have its parent's ID. So this is different. It's not just a -1. The find of 2 is per se connected to itself because it's a -1. So we will use the value of itself, which is 2. And they are not on the same set because they are not equal. Therefore, use the union operation on the value 0 and 2. When we make the union, we have to select the parent, so we have to select 2 as the parent. So we have processed the edge pair. We now then move to the next edge pair, which is 1 and 2. So just like before, we use the find operation, find 1 and find 2. Find 1 is equal to 2 and find 2 is equal to itself, which is 2. So now they are equal, which means they are on the same set. Therefore, now we have found a cycle. So that's all it is. That's how union find algorithm works. Thank you for watching the video, and please like the video. Thank you for watching.